So dear participants, let's continue our discussion with the input devices that can be attached to a PLC for certain measurements. What we have already seen that input devices are the devices that supply a signal or a data to the PLC. Now, in a very light manner, I will tell you one thing, that what actually the input device do. The input device actually tells the PLC, hey, the PLC, something's happening out here. You need to check this out to see how it affects the control program. This concept is very important. Whenever there is a change in some of the input sensors, it actually is communicated to the PLC through the sensor, definitely through the connection, and it goes to the CPU. So what the sensor tells the PLC कि भाई PLC यहाँ पे कुछ तो हो रहा है, इसको देखो और प्लीज सोचो कि इसके लिए कंट्रोल प्रोग्राम कैसे अफेक्ट होने वाला है, कंट्रोल प्रोग्राम में क्या चेंज होने वाला है. यही काम है एक इनपुट डिवाइस का. बी वेरी श्योर. Now you see, we will take up a very simple position detection application. I will not go with the type of sensors. I will rather go with some of the case studies. Okay. Now you see, in case of a position detection application, most simply, there is a mechanical switch. There is a mechanical switch which generates an on-off signal, or rather signals, as a result of some mechanical input causing the switch to open or close. Now such a switch can be used to indicate the presence of a workpiece on a machining table in such a manner that the workpiece pressing against the switch and so closing it. I will give you just this figure. You can see this is a switch. Okay. Now you can also see the connections. One of them is the NO connection, one of them is the NC connection, and there is one common connection. Suppose you have installed this switch in horizontal manner. So that the switch is there somewhere in a work table. Okay, completely flushed with the surface. So whenever you are putting some workpiece and you press it against this lever, this is the lever. I will use the laser pointer. Okay, this is the lever. When you put your workpiece in such a manner that you press it, so it is now decided by the switch that yes, the workpiece is presented. Now it may so happen, you may say, why should I press it? Because you want to know particularly, not you, actually the machine want to know particularly whether the workpiece is there or not. So this can be done very easily by putting a line on the table and aligning your workpiece with that. Now you put that line on the table, draw line on the table in such a manner that whenever a workpiece is aligned with that line, that workpiece will automatically push the switch. And if it is not aligned with the line, the switch will not be pushed. Very easily you can design such things. Such concepts are many times called Poka-yoke concepts in Toyota terminology. Now you see here, absence of the workpiece is indicated by the switch being open and its presence by the switch being closed. Now you can see here, this is the supply voltage, this is the PLC input channel. Okay, this particular line that shows that outside, on the left side of this line there is the world, on the right side of this line there is the PLC internal circuitry. Now you see that when workpiece is not present, the logic level is 0. That might correspond to a DC 24 volt input, and when the workpiece is present, it might correspond to a 0 volt input. I think I have put in a reverse manner. Oh, ये मेरे गलती हुई है यहाँ पे भैया. So you don't do this. Okay, fine. If it is the situation on the left side, okay, don't consider the right side situation. If the situation is like that of on the left side, and if supply voltage is 24 volt, then when the switch closes, what is the signal that PLC receives is 24 volt. When the switch is open, what signal the PLC receives is 0 volt. So now you can see when the switch closes, PLC gets a different signal. When the switch is open, the PLC gets a different signal. Now in this case what is going to happen, that I have written here. Now in this case you can find that supply voltage has been given to the PLC through a resistance. That means you have pulled up the PLC input channel. You have pulled up the PLC input channel to the supply voltage. So when the switch is closed, when the switch is open, the logic level is 0, and at this moment you can see with this particular figure the supply voltage is 24 volt, because when the switch is open you are getting 24 volt directly connected to the PLC. Now when you close the switch, the input channel is hardwired to ground. The input channel is straight away connected to ground. Now you get the 0 volt. So according to your situation, according to the type of PLC, in this case you are sourcing the PLC, and in this case now you understand very well what I am trying to say you. So anything can happen. You can either, when you close the switch, you want a 24 volt signal at the input, or you open the switch, you want a 0 volt signal at the input. That is possible. In this case, when the switch is open, you want a 24 volt signal at the input, and when the switch is closed, you want a 0 volt signal at the input. All such things are possible just with the help of certain change in the external circuitry. Now you see, commercially whatever the switches are available, they are of normally open type or normally closed type contacts. Okay, most of the switches, they are having both the connections, normally open connection, normally open terminal, or normally closed terminal. They are provided with the switch, and they can be configured as either of the choices of the relevant contact. So according to your necessity you can choose the contact. Okay, now I will not go for all these things. You can just read it. The NO type switch, if I talk of NO type switch, it has the contacts open in the absence of the mechanical input, and it becomes closed when the mechanical input is present. In case of NC switch, just the opposite happens. In absence of the thing, the switch will be closed, and in presence of the thing, the switch will be open. You may think why. Situation may require such type of connection. So according to the situation, you need to decide which sort of switch you are going to use. You can see this is the limit switch. The term limit switch is used for a switch which is actually used to detect the presence or passage of a moving part. Limit, ये मटेरियल यहाँ तक आया क्या, इसका लिमिट है, लिमिट में पहुंचा क्या, इसीलिए इसका नाम है लिमिट स्विच. You can see there are several structure of the dogs. This is actually the dog of the limit switch. There are several structures of the dogs. You can see a roller has been attached over here for detecting some object which is perhaps in a passage motion, which is there perhaps by the passage motion, and you need that some passing by objects has to be detected with the help of a switch. The passing by object, it can be maybe on a conveyor, it can be maybe on a roller system, whatever it is. Now you can see that this is a rotating cam arrangement, and there is actually a button. Whenever you push this dog or you take the dog to its normal condition, then the button is either pushed or released. Here you can see that there is the roller, and here you can see there is the rotating cam, and you can see the small button there inside. Okay, that is in a concealed manner, where when the limit switch, this dog will be pressed, the button will be pushed, and the switch will change its either NO condition or NC condition. This figure shows you magnetic reed switches. You can see such type of switches are also there. This is operated magnetically. So whenever that part you want to know whether that part is present or not, you have to attach a magnet over that. When the magnet is very near to this switch, both these terminals, you can see they actually get connected. So you get a complete electrical path through the switch. If the magnet is away from the switch, they are not getting connected. Okay, likewise you can even apply this for certain application. This is inductive proximity sensor, and in the below you can see capacitive proximity sensors. Many a time you are unable to see just through visual inspection whether it is an inductive proximity sensor or capacitive proximity sensor. Normally the inductive proximity sensors, mostly they are made up of metal body, and capacitive proximity sensors, they can also be of metal body, no doubt, but many a times the capacitive sensors are of made up of ABS plastic or like that. Nowadays inductive proximity sensors are also coming in ABS plastic body. So you need to know actually from the this manufacturer's tag that is over there whether the particular sensor is capacitive or inductive type. This is the symbol of an proximity sensor. Now you can see this patang shape, this rhombus shape along with this vertical lines that shows you that this is a proximity sensor. Now this shows you that it is giving an NPN output. Whenever the FE is written, that is an inductive type, and this thing shows you that it is a normally open switch. This is the typical symbol of the normally open switch. Now remember that how to wear this. Already I have shown you in my earlier lecture. Now you can see that there are three wires. One is brown, other is the black, and this is the blue. You can see this is NPN type. NPN is a sinking type, and therefore we have connected the load in between the output and the supply. So whenever the signal it is NO type, whenever this signal is NO type, and we have already told that whether the sensor is NO or NC, that has nothing to do with the NPN or PNP characteristic of the sensor. These are completely different. But you can see that since it is NPN, we need to connect the load in between the supply and the output. And whenever the signal, the sensor is activated, current will be flowing through the load. Okay, so this is the thing. Again, you can find that the source that you can apply for the sensor is 12 volt to 24 volt. Now you can see what is the wide range of voltage that you can apply, supply that you can apply to the sensor. So this is very important. Most of the industrial sensors nowadays, they can accommodate a large window of supply voltage, and therefore it is very flexible to connect them to any of the operations. Now, so far the position detection application is concerned, we also apply several type of optical sensors. If we want to classify the optical sensors, then they are primarily of three types. One is through beam sensor, the other one is diffuse reflective sensor, and the third one is retro reflective sensor. Now you can see, as the diagram suggests, they are very easy to be understood. When you are having an object that has to be detected within a source and a detector, you can use a through beam sensor. So as I have already told you that there is an optical path in between the transmitter and the receiver. TX denotes the transmitter, RX denotes the receiver. So there is an optical path in between them, and whenever the source, it actually generates the optical signal that is received by the receiver, and the receiver generates a detectable signal at the output. Whenever the object is there in between the transmitter and receiver, and it is breaking the optical path, then there will be absence of the signal at the output. Or it may happen that whenever the optical path is continuous, then it will give no signal, and whenever the object is there and making the optical path discontinuous, then the RX unit will be generating a signal depending on the NO or NC connection which is available at the output. In case of a diffuse reflective sensor, the transmitter and the receiver are embedded on the same body. They are embedded on the same body, and here reflector is the object. Earlier the object was breaking the optical path, but here the object is acting as the reflector. So what is happening? The transmitter is putting the light here. You can see it very correctly that here the light was a straight optical path, but here the optical energy is a bit oblique, or I should say definitely a bit oblique in nature. Now why it is oblique? Because unless it is oblique in nature, it will not be reflected. So it gets reflected, and then it is reflected to the receiver, and the receiver generates the signal. You can understand one thing very clearly, that in order to work with diffuse reflective sensor, you cannot have a very large range. Okay, so if the range is very large, that may go out of the range of the transmitter. So therefore, when you are trying to apply a diffuse reflective sensor for certain purpose, please know what is the range of that sensor. Next, you have got a retro reflective sensor. In case of a retroreflective sensor, again the transmitter and the receiver, they are embedded on the same body, and there is a specially designed reflector. So the transmitter actually sends the signal to the reflector reflects it, and when an object is there in between the transmitter and the reflector, then this object will be detected. Now they have got several different applications. I will not say each and every application. I request that you go to the Omron website, Omron website, and try to see what are the different type of optical sensors they use, what are the different type of applications that can have. I will try to definitely share the document with you. So this is, you have got an idea of how this position detection application is carried out with the help of this basic three type of optical sensors. Now let us see, these are the commercially available through beam sensors. One of them is transmitter, other is receiver. You can see here, this is the transmitter. From this small orifice actually a laser light that comes out, and this is the receptor. You can see here such type of arrangement. These are not very costly sensors. If you go to even market, you can find at a very low cost for low end applications definitely. Here you can see the source and detector are mounted on these two limbs of the structure. This is one limb of the structure, this is another limb of the structure, and this is particularly used for rotating discs with orifices onto that, so that when the rotating disc is put in this particular material, and the rotating disc is having holes at its circumference, okay, continuous holes at its circumference, one hole, some gap, another hole, some gap, another hole, like that. Then if the disc rotates, then light will be at one point, it will be passing, and the other point it will be stopped. On one point it will be passing, the other point it will be stopped. So what you are getting actually a train of pulses at the output. I will show you over here that I had put in the case of an encoder. You can see here, from here you have the source, okay, and here you have the receiver. Now you can see the source is trying to pass the light through this disc, which is having certain graticules onto that. These are the graticules. They have been designed in such a manner that it is completely through the circumference at perfectly situated distances. Now whenever the graticule is present, light can pass. Whenever the graticule is not present, the light is not passed, the light is stopped. So accordingly you can get the signals over here. This is a retroreflective type sensor. You can see this is the sort of transmitter, and this is the receiver. Again, this is the transmitter, this is the receiver, and this is diffuse beam sensor. You can see this is the transmitter and this is the receiver embedded on the same body. Such type of sensors are also used in retroreflective type. But you can see that if you are using this particular unit, that is the transmitter receiver unit, that has been designed for a retroreflective sensor, and since this unit and this unit, both of them looks just like alike, you want to use this as a diffuse beam sensor, it is not going to be successful. So please don't do that. Please try to apply the sensor for which it has been made and according to the manufacturer's nomenclature and manufacturer's application note. So I will stop here, and in the next lecture I will come up with another aspect of this detection applications. Thank you.